Where conceptual modeling. In this section, we'll be talking about how to model a database, how to graphically represent a database such that we can able to get information and see how information flows in the database. So basically, conceptual modeling helps us to understand the flow of information in a database. And mostly in a conceptual model, we will be using the ER model. The ER model is basically a form of model where it deals with entities, attributes, and the relationship between entities. ER stands for Entity Relationship Model. And in this entity relationship model, we'll be using the ER diagram, the entity relationship diagram, to graphically represent this model. Now, what is an entity? An entity is anything in the real world, physical or abstract. An entity could be a person, an entity could be a student, an entity could be courses, item, or a product. Anything that has properties can be an entity. For example, student can have properties like the name, the date of birth, the place of birth, the age, and many more. Anything that can come as a property of a student makes student an entity. If you're designing a student management system, you will likely have an entity of student where you will store students' record, and you will store record like the name, the age, the date of birth, the place of birth, the program, and many more. So whatever things you can store under a student makes student an entity because it has properties. Entities are represented by a rectangular box with the name of the entity in between. For example, I can have this rectangular box with the name student. This is a graphical representation of entity in the ER diagram. An attribute. These are properties of an entity. So if I have an entity person, social security number, name, age are the attributes of a person entity. Entities are represented by an oval shape with the name of the entity, like social security number, name, age are represented with the oval shape and they are linked to the entity. So this is how we represent entity in the ER diagram. There are different types of entity. We can have a simple or we can have a composite entity. We can have a single value or we can have a multi-value entity. We can have a stored entity, or we can have a derived entity. Now there is a specific set of entity or an entity which has a unique value for every record of that entity. For example, for every record of a person, we have just one record of a social security number for that person. So the social security number is known as the identifier because it identifies each person in the person entity. So that unique attribute, or it could be a group of attributes that can uniquely identify each record of an entity is known as the identifier. So for example, if you have an entity student, an identifier could be the student ID because we have only one record of student ID for each record of a student. An employee ID could be another example in an employee entity. For every record of an employee, we will have one record of the employee ID. Now for the different types of attributes, we have single or composite attribute. A composite attribute can be broken up into meaningful parts. For example, we can have an attribute called name, which can be broken down into the first name, the middle name, the last name. So this is how we represent it in the arrow diagram. So we have the entity, the attribute, and we have the different meaningful parts broken. Now a simple attribute is just a normal attribute linked directly to the entity. But the composite attribute is broken down into different types. Now for a single value or the multi-value attribute, there can be certain kind of attribute that has many values for a particular record. So for example, in a person entity, we can have a person having many records of email. So you can have different emails, but you have one age, you have one name. So the name is a single value attribute because you can only have one record for that one person. The age is a single value because you can only have one age for a person. But the email is multi-valued because we can have different emails. You can have a Yahoo email, you can have a Hotmail, you can have a Gmail, and different email accounts for a single person. So we represent this multi-value entity with a double oval shape lines. And this entity, we have the same data type. We will see more about data type in the later part of this course. But if I'm storing emails in my database, I can only have one data type to store all the emails. Is example of such is an array. An array can have is a data structure with a single data type. So I can only store my emails if I'm storing a string or a variable character. I can only store variable characters as email. I cannot put a particular email with a variable characters and another email with a date. So all of them has to have one data type. Another kinds of attribute is or are the derived or the stored attribute. The derived attributes are attributes that can be gotten from another attribute. So if I can compute or calculate the age from a date of birth, then age is a derived attribute because age can be calculated from the date of birth and from the current date. Now a name is a stored attribute. It's a simple attribute and it's a stored attribute. I can store it in the database, whereas the age I can calculate it from another attribute. To represent derived attribute in the arrow diagram, we use broken lines, broken over lines. So the oval shape attribute will be represented in a broken line like this in this diagram. Now in this part of the course, we are going to take an exercise to see if we have comprehended the different kinds of attributes and entities and how to represent them in the arrow diagram. So in this exercise, I am calling it person. We are going to produce an arrow diagram for the following situation. We have only one entity called person. Everything else is represented as attribute with the following attribute. The ID is the identifier, the name, which is a composite, which is composed of two or more given names and one or more family names. We also have one or more aliases, and we also have address, which is composed of a street, city, state, and a zip. We also have the date of birth, and we also have the age, which is calculated from the date of birth. So how do we represent this information about a person using the arrow diagram? I would like you to pause the video at this moment and try to sketch out your representation of the arrow diagram But in the next slide, I'm going to show you the correct output so that you can able to compare with what you have done. It is very important you follow up with this exercise because it will help you to understand the different kinds of attributes in an entity. Now this is the solution of the exercise we just have. So we have the entity person, which has an identifier called ID, and we represent identifier with a line under the name of the attribute. So we have ID and we'll draw a line. It represents that this is an identifier and it has just one value for every person in this database or in this ER diagram. So we also have a name, which is composed of a given name and a family name, and a given name, which are composite. So which have different values. So I can have different values of a given name. So I represent it as a double over object, making it a multi-value. So I can have different given names, and I can also have different family names, which I represent it as a double over of a shape, which representing a multi-value attribute. And I can also have aliases. Aliases also have different given name, different values. I represent it as the over shape. Now if we look at the name, especially the name is a composite attribute, and also each root of the composite attribute is a multi-valued attribute. But for the alias is just a simple multi-valued attribute. Now the address is also a composite attribute mixed out of the street address, the city, the state, the zip. So all these are the different meaningful parts of the address. And we also have the date of birth, which is a simple attribute. And we have the age, which is a derived attribute, showing that it can be calculated from another attribute, which is the date of birth in this case. So basically, this is the representation of the person object as described in the exercise we just have. So we have a person, we have the ID as the identifier, the name which is composed of the given names and the family names, and it can have one or more given names and one or more family name, making given name and family name multi-valued. And we can also have one or more aliases, making aliases a multi-valued attribute. And we can also have address, which has street, zip, city, state, and zip, making it composite. And we can have date of birth, which is a simple attribute. We can have the age, which can be calculated from the date of birth. Now, as a recap of what we have done in this section, we have talked about entity, we have talked about attribute, we have talked about different types of attribute like the simple and the composite attribute. We have talked about the single and the multi-valued attribute. We have talked about the stored and the derived attribute. And we took an exercise where we struggled to bring out the different kinds of attribute in the person entity. Thank you for joining me in this lecture. I'm happy and I hope you enjoy the lecture. See you in the next lecture. Bye.